So with all our blessings, so we would like to have the first speaker, opening speaker of this 6 days online FDP on IoT and cybersecurity in power system. So I'm very glad and be very happy to introduce our first session speaker, Dr. P. Chidibabu sir. So Dr. P. Chidibabu sir has received his PhD degree in electrical engineering from National Institute of Technology, Roorkee, India in 2012. He was an assistant professor in the Department of Electrical Engineering at NIT Roorkee in India for 6 years from 2007 to 2013. He has his postdoctoral research appointments with Wrocław University of Science and Technology, Poland during 2013 to 14, and with VSB Technical University, Ostrava from Czech Republic. Both of these appointments were sponsored by European Commissions. He was an assistant professor in the Faculty of Engineering at University of Nottingham, Malaysia campus. He's an assistant professor at present in Indian Institute of Information Technology, Design and Manufacturing, Kanchipuram, Chennai, from June 2018. Since August 2023, he has been appointed as an associate professor in the same campus. He was a visiting researcher at Politecnico di Milano, Italy during 2015, and visiting scientist at Yıldız Technical University, Turkey from 2019. He's a recipient of Young Systems Scientist Award 2019, sponsored by System Society of India. He has received Outstanding Teacher Award 2023 from IIIT Chennai for his indispensable contribution in teaching. He's an editor-in-chief for various journals like IET, Renewable Power Generation, Energy Systems Integration, Taylor and Francis, etc. He has undertaken many research projects with the worth of 1 crore sponsored by the Department of Science and Technology from Government of India. He has published over 70 research papers in Science Citation Index journals, including IEEE Transactions. His current researchers includes power electronics application in smart distribution grids, containing renewable energy sources, design of low-power photovoltaic systems, including MPPT algorithms of renewable energy systems. Sir, we are very much gladful to have you, sir, for today's session, and we would like to hand over the session over to you, sir.
Let me share my screen. Is it visible? Is it visible now?
Yes, sir. It is visible, sir. Yeah.
Yes, sir.
Yes, sir. Yes, sir.
Yeah. Thank you very much, Professor Nyanambike, and thank you for such a very big introduction and about me. But still, I feel and blessed with the student, and as a student and as a teacher and a learner, and still I feel that so I'm an academia. So sharing my knowledge to the students is very vital. And thank you very much for inviting me to be a part of this Atal FDP. And it's my great pleasure and privilege to deliver a first session on this particular FDP with the title Internet of Things in Electrical Power and Energy Systems. The title seems to be quite interesting, that the participants may be from the background of electrical engineering, and maybe there are such areas that include power electronics, renewable energy, and power system. Maybe few of the participants might be working in a smart grid, right? And even a few of the participants might be working in electrical vehicle as well. This is a very comprehensive idea about the smart grid and the Internet of Things in modern power system. Yeah, largely we call it as the Internet of Things in a smart grid, right? And how the system is being made very smarter in the 21st century. That and we are in a very comfort zone thanks to Internet of Things, right? Let me start with the preamble and the preface that all of us know that these electrical power and energy systems provide clean energy for sustainable. Let me make the lesser pointer. Yes, sustainable growth. And of course, this Internet of Things is at the forefront of this transmission importing capabilities, because the Internet of Things is one of the gravitated development and the reforms in modern power system. All right, this Internet of Things was a technology that was developed by the engineers from Massachusetts Institute of Technology in the year 1999. And this IoT technology has been adopted by a number of countries, including US, Japan, and India, and China, and the European Union as well. Of course, this Internet of Things can effectively integrate the infrastructure resources in communication systems and the electrical power system, and of course, to improve the efficient utilization of electrical energy, right, as it meant for the real-time monitoring or intelligent control and cyber securities as well. Of course, the electrical power system is being largely enabled with intelligent cyber physical system, which is one of the very efficient and secure and reliable and resilient and sustainable component in power system. And in addition to that, of course, as we are digitizing this electrical power ecosystem with the help of this Internet of Things, of course, it largely improves the asset viability and optimal management of distributed power generation, so particularly on the solar photovoltaic or wind energy conversion system, that it largely eliminates the energy wastage and creative savings as well. Right, and the IoT has created, significant impact on electrical power and energy systems for several opportunities for the growth and development. Right, of course, there are several challenges with the deployment of IoT. And all of us know that because the implementation of IoT in power system is, of course, it rely on the line monitoring, right? And the line monitoring and also the real-time control in all aspect of great parameters. All right, that parameters include voltage and frequency, active power and reactive power, and power factor. All right, and also that would rely on the basic characteristics of the grid information. Of course, the communication and automation as well. Of course, and the IoT that become a vital component of modern power system. All right. As all of us know that these major drivers of the transformation in electrical power industry, as it's in association with the decarbonization of electrical power and energy system, there would be a decentralization of electrical power and energy production and the transportation and the electrification as well. Because all of us know that in the conventional power grid, as the electrical energy is being traveled in a unidirectional manner, and as from the generating station to the consumer premises following a common right-of way, and of course the end users that finally they get the power. Of course, this unidirectional flow is defining the characteristics of conventional power system. That is what we call it as a centralized power system, because that provides a centralized control and monitoring all vital in this grid to maintain the balanced power generation and the consumer demand within the constrained power system. Right, as always, we are inclined towards making the power balance between the supply and the demand. And of course, many of the utility companies, they're responsible for overseeing the entire process of making the supply and the power mismatch, and which includes, of course, the generating power and the transmitting power and the distributing of electrical energy. Right. So their role extends to supplying the electricity to the consumers, implementing bill practices, of course, that ensure a cost recovery and a profitability as well. Right. And in the 21st century, and still the growing demand of electricity, and because of the future energy demand that increases very drastically, and in that situation, integrating renewable energy sources with the existing utility grid and making the inconsistent communication and the surveillance, of course, it makes the inefficient routing and the distribution. So and that is what we are in a situation to have IoT assisted modern power system of the smart grid. So this transformation, the EPS, they emphasize increasing the efficiency and improving the reliability of electrical power networks operations and energy conservation and reduction of CO2 emissions as well. Now, understanding in the 21st century that there would be a large reduction in the renewable energy power generation, that taking an example of silicon photovoltaic model with mono or polycrystalline and even lithium-ion electrical vehicle, the battery back. So now you understand that the cumulative production of electricity demand that has been increased very drastically, and however, the cost of the electricity production it decreases drastically. It is what you can understand, that as the cumulative power production increases, of course, the size and the cost of the solar photovoltaic array decreases. Right. So, of course, as I said, the major drivers of this transformation in the electrical power industry, of course, decarbonization and the centralized power and energy production, in addition to transportation and electrification as well. Right. And with this aspect, as we are going to make the stochastic nature of these renewable energy sources, of course, we need energy management system. Right. So this energy management system, of course, that it makes sense in integrating these renewable energy sources and the solar photovoltaic in addition to the conventional power plant, and having a very automatic car parking, for an example, that is IoT. that they can transform these electrical power energy systems by providing a sustainable solutions for example, a dynamic stochastic energy management system. Because the introduction of this the smart grid technology with the help of IoT, it addresses some of the challenges, because this IoT-based smart grid that incorporates advanced metering infrastructure and makes sense in bidirectional power flow and making two-way communication technologies, and it making a decentralized power control and decentralized power control in terms of the minimizing the power flow from the grid, and as it uses the renewable energy technology and the time of use rate, and further it enhances the power flow of the utility grid with the help of this Internet of Things in this modern power grid, right? And of course, this makes sense in the incorporation of more effective handling of energy distribution and improved renewable energy sources, and it makes sense in enhanced surveillance and the responsible opportunities as well. Of course, that enhances the problem associated with the blackout and brownout. This problem is going to be largely handled with this IoT, so that it makes sense in modern power system. That is, of course, it is what is called IoT-based power system, right? And understanding that, and the IoT, very first, this technology is being used in modern power system as understanding the power generation and the transmission and the distribution and having the consumer premises, and all of us know that the typical power system that has the power generation, the transmission and distribution, the consumer premises, that here, as you are going to incorporate the Internet of Things in this power system network, of course, this IoT that requires for the power system, because that must rely on the line monitoring, as I told you, that monitoring the grid parameters like voltage, current, and frequency, active and reactive power. In addition to that provides a real-time control in all aspects of grid operating parameters. As I told you, that in addition to that, it has to monitor and diagnose the basic characteristics or that grid information, the communication, automation as well. Right. So of course, as incorporating this Internet of Things in the modern power system, or maybe in the smart grid, and that makes sense in an important technical support for the power system. As I told you, that the real-time monitoring and asset management, and of course the fault detection of the generation, transmission, and distribution, as well as the electricity tariff monitoring and other aspects of power grid. So it largely enhances the performance and utility of the utility grid. This is one of the very important thing in application of Internet of Things in modern power system. Of course, as I said, there are two important challenges in modern power, existing power system. One is in the blackout, right? So when the grid faces the difficulty of the unsymmetrical or the symmetrical fault, of course, it faces the problem of the blackout. And in addition to that, the stochastic nature of these renewable energy sources, it causes the problem of uncertainty. So it is very difficult to forecast the electrical energy, especially renewable energy sources. Typically, take an example of solar photovoltaic. Right, and moreover, as all of us know, that in the countries like India, about 30% of the electrical energy is being lost in the transmission line, and 40% in the distribution system itself. So, and understanding or how to detect the power theft, or how could you minimize the losses in the transmission and distribution system. In addition to how would you identify the fault that occurs in either in the transmission line or maybe in the distribution network, and it largely enhances the reliability of the power system. That is what. So in the modern era, that as we uses the electronic units should compulsorily have a smart meters to support this IoT-based smart load forecasting as well. Right. And as we are deploying this Internet of Things in modern power system, there will be significant energy savings, because it minimizes the line losses and the distribution losses, having the software enabled system that it is easily minimize the losses by having detection on the power failure or the power theft. And it also helps the users to reduce their energy usage and to save money as well. And in addition to that, having sustainable practices, because this IoT can help users to adjust their energy consumption based on the actual need, as we use the smart metering concept as well. And it enhances the reliability of the power system, because as we are able to detect the fault, and also so that as the grid is being very smarter and becomes smarter and smarter, and it's able to heal the fault. That is what it has a very self-healing properties. It is able to detect and recover the system against any fault condition. So it largely enhances the reliability as well. Right. In addition to that, this IoT allows for more accurate communication between the power station and the grid as well. Right. As simply, I can say that this IoT can effectively integrate the infrastructure, resources, and communications and the electrical power system and improve the utilization efficiency of the system. This is one the benefit now, and this IoT become a part of the modern power system, or maybe a part of the smart grid as well. Right. As deploying this Internet of Things in modern power system, of course, the power networks that become very intelligent, because this intelligent, why the system is called as intelligent, because this intelligent power network is automated. Right. Automated means it has a processor with the control that is being automated with the help of the advanced DSP, or maybe a kind of APG, or maybe the PLC based control. What we could say that the classical power system is called SCADA. So you try to make the power network is highly automated. It makes sense in monitoring all the parameters, either in the form of generation parameter and the transmission parameters, or maybe the auto distribution parameters, and making very flexible in handling the active and reactive power flow with the help of power electronics devices, called it as FACTS devices as well. And make your power network is very intelligent, so that it has a self-healing property whenever there is a fault, of course, in the utility grid, and it makes sense in the robust control on the robust control and regulating the active power and reactive power in terms of voltage and frequency control thanks to power electronics. And it makes sense in consumer-centric network that support bi-directional flow of electricity and the data. This is what now modern power system or modern power network is called. It is intelligent electric power network thanks to IoT. Right. So this intelligent power network is the integration of course, the cyber secure technologies and intelligent device communication, of course, the high penetration of renewable energy generations that create a resilient and the reliable and the safe, sustainable energy delivery network. Right. Of course, as I said, this the smart network or smart grid that has a self-healing and intelligent measurement and control capabilities. The intelligent electrical power networks have several advantages, as I told you, that it makes sense in enhancing the energy efficiency and reduced running cost and better demand supply responses, and in addition to reduction in the transmission and distribution losses. Right, and you understand that this IoT was deployed in the USA in the year 2007 and started with the transitioning to the IoT technology in the grid, and that has made it with the IoT based devices, and they could invest in terms of $1 trillion for developing IoT for existing power system. Of course, very first this IoT technology was used in overhead transmission. Not only in the overhead transmission line, and also in the distribution side to monitor the grid parameters in addition to detect the fault, so that it largely enhances the reliability of the power system. Right. And now, as I said, everything is of IoT. As it made the system is very intelligent. Of course, as it's trying to make the deployment, the transformation between these three important things. One is the traditional electrical power and energy systems, of course, and what would be the identifying new renewable sources, and what would be the balancing fuel mix, and with the asset level visibility and the technology integration. And of course, the final ultimate aim of this classical power system is to enhance the reliability of the power delivery as well as the power quality as well. Right. So now, as this is being made it very intelligent electrical power energy systems, making the application of the services maybe in terms of electrical power generation, monitoring and control, and the electrical power transmission and distribution network control and the monitoring. In addition to the make the sense in energy efficiency or reducing the running cost. Having the home, it seems to be like a very smarter home, because as we have a smart metering and we are able to monitor real-time monitoring of all the power that is being consumed by the consumers, in addition to promote any power theft or improving the power quality as well. Of course, as it makes sense with the smart parking mechanism of how the power is being distributed and effectively utilized for either electric transportation and the smart car. Right. Of course, the ultimate aim of promoting this IoT or intelligent power network for economic impact and environmental impact and the societal impact. Right. And now, what would be the constraint in deploying this IoT in electrical power system? Right, and understanding someone that very first thing, as you are incorporating this IoT for power management, right? So to make the power balance between the generation and the demand, right? Of course, as the that power regulation that is being sensed very first with the help of sensor. Of course, sensor is a vital component of IoT in power system, and making sense that as the problem is being completely monitored with the help of this IoT, having good connectivity, either with wired communication or maybe wireless communication, and having the processor to have a large computational requirement with the big data and the security, but still the system is very complex. Yes, how would you be able to implement the system? Still, it is a very challenging task, right? And understanding that now, and the role of IoT for intelligent power network, as I said, there are several benefits of deploying this IoT, enhanced reliability and the relationship and adaptability and the energy efficiency. Of course, it reduces the large number of communication protocol, so that if the network operator can enhance the operation information capabilities, it improves the control over home appliances as well, as the home is becoming a smart home, and it's enabled on-demand information access and end-to-end service provisioning, and improved sensing capabilities. As we use the very smart sensor, it is able to precisely detect the grid parameters like voltage and frequency, and it enhances the scalability and the interoperability, and reduce the demand from the natural disasters as well. It reduce the demand damage from the natural disasters, as we have a real-time monitoring, and it reduces the physical attack as well, because we have a cyber security and is able to continuously monitor the electrical power networks, so that it makes sense in improving the automation as well as the control of entire electrical power system. Right. As I meant that now with the help of IoT in the power system that is making intelligent, still it is being digitizing. The network is becoming very digitizing electrical power network, right? Because as I told you, this existing electrical power transmission and distribution network, it faces a number of challenges. I told you that, including delayed outage response times, because we use the electromechanical relays and the circuit breakers, and detecting the fault and clearing the fault. It makes sense in the response time in terms of minutes, and still the power loss is quite larger in transmission as well as the distribution side, and there would be a data theft and distributed energy resource integration. These all are the possible challenges in the existing power system, as making the digitizing the existing power with the transmission and distribution network with IoT can alleviate this all the challenges. Yes, as I tell you that this IoT can help reduce power losses and the data theft during transmission and distribution by adjusting the electrical parameters. As I said, our ultimate aim is to automate the power system. It makes you have a very deregulated energy environment, so that the power is being monitored and regulated in a real time. You are able to provide a monitoring as well as sensing and control, so that you make your complete system is automated, right? So IoT can help reduces the power losses and the data during transmission and distribution by adjusting the electrical parameters, maybe in terms of voltage, active AC voltage and the AC current and the power, and active and reactive power and the phase and the frequency in a real time by tracking source of theft respectively. Yes, now understanding that how IoT is being used in the home. And this is what is called the smart home with the intelligent load. As you have in a smart home, as we have a rooftop solar photovoltaic, as we have this, all the appliances are basically smart appliances, and having a kind of remote controlled fan, and having the air conditioner and the television, smart television. We have an energy storage in association with the home is being connected with the electricity or utility grid as well, right? So now, as your entire home is going to be automated, as it makes sense, a two-way transfer of power with other network constituents as well. So now you see all the number of all the homes in the particular area is being fully automated. It's being connected via wireless communication system, right? So now you understand that this makes sense in central energy management system, so that any power demand exceeds certain threshold in a particular home, that is being indicated by the sensor along with the smart meter, so that we are able to cut out the power, or we are able to make the load shedding. So it means in overall we try to maintain the power flow and enhances the reliability of the power, reliability of the home without any outage. And moreover, as it makes sense in that when the demand is very low, and the sensor is being sensed from the grid, so that when the power demand is very low, sometimes the grid power may be disconnected from the load, so the load gets power from the local solar photovoltaic via energy storage. So it makes sense in efficient utilization of energy with the help of renewable energy as well, Right, and this is what the system is becoming very smarter, and the home that becomes very smart home. Right, as making this smart home environment, as you can understand that with the help of deploying this Internet of Things, that is the real time wealth of the knowledge with IoT, as what you do as we have a smart home. And as we sense all the parameters with the help of IoT sensors, then the sensor, it sends all the parameters of the home that gives information to the real-time wealth of the knowledge, and based on the demand and the supply, and of course it takes senses and with the visualization of all the control, and it follow the sense making and decision making and the adaptation, so that it is overall trying to make your home is very smarter. Right. Simply as we use IoT even for smart park mechanism, that how the parking is being done with the help of IoT in the existing power system. Right. As we have here the smart parking maybe in the bus 2, and the smart parking in the bus 3 as well, that is being connected with the low voltage distribution transformer. Here the vehicles are being charged in the smart parking mechanism. Right. So how would you make the smart monitoring of in this particular power system? Right, and then this makes sense because of the deployment of this Internet of Things in the existing power network for what is called the smart parking mechanism. This is well implemented in many of the European countries, and all of us know that. All right, and as I told you that, and the IoT sensors are the key drivers in contributing to the growth of the microgrid or nanogrid, or maybe smart home with the intelligent load. Of course, the loads are IoT enabled to load, and electrical transportation, and its distributed energy sources as well. Now you understanding that as the sensor is a very important component of this Internet of Things, and different types of sensors are commercially available as we use for smart home energy management system, or maybe for electrical power and heavy systems as well. As you understand that according to the occupancy. Yes, as we make for example, the smart house automation as we use for smart lighting mechanism. So it means, and we know that how the smart lighting scheme that it works. So once the person or the someone is entering the corridor, then of course the motion sensor that will detect the human being, someone is walking on the corridor, then it will give, it sends the activator, then immediately switch will be closed, then light will glow on the particular area. So once someone crosses the corridor, of course it finds that no one is standing in the corridor, immediately it gives the information to the actuator, so that it will switch off the light, so that you follow the perfect monitoring of the lighting system. Right. So this is what many times we use for occupancy sensor, especially for the smart lighting mechanism. And as this IoT sensor, then further they classified into the smart sensor, motion sensor, or maybe open or close sensor, or maybe perimeter sensors. Right. And in terms of different names as it's commercially available with, and further for environmental sensor. For example, as I use renewable energy for my home, and solar photovoltaic that is at the rooftop, and how would you sense, how would you make your home is very smarter? Sometimes we may use environmental sensor. Yes, and what would be the weather, and what would be the humidity, what would be the temperature, what would be the irradiation, and this all can be measured with the help of temperature and humidity sensor, maybe in the form of Minatar engineering and Windlamp electronics and Logras technology. These all the supply manufacturer who manufacture different types of sensor for temperature and humidity, and still sometimes we can find the kind of leak of the water sensor, and Instein or maybe Windlamp electronics and Skyline technologies, maybe in the form of smoke detector. Right, or air detector, and maybe first alert and the universal security instrument or 2G, IG technologies as well. But still many times we use light sensors as well. Right. And for IoT power monitor, as we monitor the active and reactive power in the utility grid, as well as for the power consumption, we may use an IoT power sensors as well as other IoT sensor in terms of what dry contact sensor, or maybe smart plug, or maybe a current transformers, and AC and DC voltage sensor, and power synchronizing sensor, and smart home monitoring kits as well. Right. And of course, these all power monitors sometimes we may use with the supplier, with the P3 International or electronic educational devices and energy incorporates. Right. So as with the help of these different types of sensors used in IoT enabled smart grid environment, this sensor help minimize the energy wastage because it has an accuracy in detecting either smoke or the light or maybe any environment parameters like temperature and radiation. It largely reduces the cost and actually monitor the home environment. Of course, they reduce the risk of harmful environmental exposure such as carbon monoxide or smoke, or make home life more convenient and comfortable. Right, and the constraints on other hand, what are all the constraints in promoting this IoT based electrical power and energy conversion system? Maybe developing a smart control algorithm to improve IoT sensors power and fault tolerance and bandwidth is a very challenging task there. Because controlling and active and reactive power is not easy because the grid power is an AC power, right? So AC power having in sinusoidal voltage and currents having always inherent coupling between the active and reactive power component. So decoupling the voltage and the frequency of AC is very difficult. And this is what even we go with any power electronics based control and the utility grid, but still making a smart control algorithm for such system is a very challenging task. And that is what, because IoT sensor can sense active and reactive power that may detect any power failure, but it be able to control. That is what we use as IoT. In addition to that, we use power electronics converters and the renewable energy are in the modern power system. And the integrating the robust communication technologies. As I told you that in some sense we may use kind of IoT based sensor, right? IoT sensor network to resolve a communication network issues, maybe in the form of wireless interference and the packet losses, or maybe in the transmission error. And sometimes we may use the robust communication technology like a PLC or SCADA as well. But still, sometimes as they use the sensor integrating the gesture recognition of the brain-computer interface with the IoT sensor to better monitor the physically impaired and elderly as well in the smart home environment, and implementing energy harvesting technology in IoT sensor to do away with the batteries. That is another important challenge in promoting IoT in the smart energy systems. Of course, reducing the complexity of the program platform with the IoT sensor network to enable average users program them as right, and employing aggregation-based data privacy and preserving protocol to secure the IoT sensor data is still a challenging task. And in addition to that, analyzing the privacy and the cyber security risk in IoT devices and the software for smart home automation system. Of course, as we need advancement in the detection technologies to counter cyber attacks, and this is what now the research and development is going on in IoT, especially on cyber physical system. And how would you, detect the power theft, and how would you, encounter the problem of the cyber attack in a smart grid environment, right? As I told you, apart from the monitoring and monitoring these grid parameters are the condition of the grid, including the grid fault type. But still, power management is a very challenging task in the 21st century. First of all, the power management solution, the recommended solution to overcome the power management challenge in IoT is first of all promoting energy harvesting system and energy storage. Because as promoting this energy harvesting and the energy storage, it makes sense in balancing the power flow between the demand and the supply, so that it will regulate the supply frequency, right? As I said, the frequency is a key component of the utility grid that governs the power system security. And whereas the grid voltage, it largely decides the power system reliability. So enhancing the reliability and the security, it needs an urgent control of voltage and frequency in the utility grid. So that is what we promote energy harvesting technologies like the solar photovoltaic or wind energy conversion system. In somewhere we use hybrid energy combining two or more renewable energy sources via battery. That is what the renewable energy sources are becoming a distributed generation, right? What is a distributed generation? Renewable energy sources are associated with the energy storage that provide affordable power to the local load that makes sense in grid independency. That is what they call it as a microgrid, right? So this all possible with the energy harvesting system and the energy storage, in addition to energy efficient communication protocol and the communication networks. Yes, now as we from electrical background, we focus more on energy harvesting system and energy storage, and in IoT based electrical power and energy system. As out of all the different energy sources, and all of us know that the solar energy is emerged as one of the most promising renewable energy source in the 21st century. in 24 June, about 37% of the total installed capacity is by renewable energy sources, particularly from solar photovoltaic. Right, because solar energy is freely available. All of us know that it's a byproduct of solar energy. The universe of energy is the sun. So we used to, use that sun energy in the form of light and temperature, and we are able to convert that into electricity with the help of deploying solar photovoltaic cells. That is basically silicon semiconductors. So it is easily accessible energy source. The amount of energy harvested from the solar is 24 milliwatts per square centimeter, right? And you can use a kind of any solar cell. It is able to harvest the energy with in the order of millivolt, so that by increasing number of cells in series parallel, we are able to harvest the energy in the form of watts, kilowatts, and megawatts. Right. Of course, the problem associated with the renewable energy is that the energy is uncontrollable. All of us know that. Why the energy is uncontrollable in solar photovoltaic wind energy? Because it is naturally available. There would be a inherent non-linearity in the solar energy, or maybe in the energy that is available in the sun, because that varies, depends on the climate and the weather condition, of course, but predictable. So you are able to predict it, but you cannot control. That is what these generations are basically uncontrolled power generations. They call it as intermittent power generation. They call it as disposed power generations, right? But still, the solar panels can be made small enough to fit a form factor of wireless IoT sensor network, sometimes we use for energy harvesting as well, right? And in addition to that, in the energy storage systems are very prominent in modern power system to make the system is very smarter and smarter again, because the amount of energy is being stored with the help of storage devices, and they are able to release the energy in a very short duration according to the demand. Especially these energy storage devices, they control the energy, and they control the frequency by maintaining or by making the demand it's at par with the supply. Right, and this is what we use energy storage devices. It become an inherent part of modern power system. You can't imagine without energy storage today. Yeah, why? That is what. So storing energy when renewable power is enough, right? And releasing power when renewable power not sufficient, right? When the demand increases, if the renewable energy is not unable to meet the demand, then the energy storage will support you. So it is making sense of power balance between the supply and the demand, right? Different types of energy storage devices are used in IoT-enabled smart grid or maybe electrical power energy system that include batteries, right, and hydrogen tank, and other energy storage devices are like ultra capacitors and super capacitors, or flywheel energy storage, or maybe superconducting magnetic energy storage as well. Right. As we use these renewable energy sources, the energy storage devices in modern power system, let it be an IoT-enabled modern power system, but still these energy storage devices cannot instantaneously supply the power according to the demand. Of course, the power control is very essential, right? So power flow regulation is very essential thanks to power electronics, right? So no energy storage devices can be used alone with the existing power system or modern power system. We invariably use power electronics converters, right? Because as the power electronics converters that control and regulate the power flow, which makes the power flow is bidirectional between the energy storage and the utility grid. They provide you for charging energy storage devices when abundant of energy is available with the renewable energy, for controlling or for converting the voltage in appropriate format, and that voltage is well fed into the utility grid, and also it is important for achieving maximum power by tracking, because all renewable energy storage devices, they operate at a very low efficiency, so they invariably uses power electronics converter to extract maximum possible power with the help of maximum power by tracking. Right, and let us talk about the battery energy storage system in the modern power system. Of course, the battery energy storage, it is most widely used for solar photovoltaic, for grid connected as well as standalone system, because as all of us know, that is a simple PV solar photovoltaic panel which is made up of a silicon cell. They're embedded in a glass envelope. They simply connected in series parallel to have a required power and voltage rating. So when the irradiation falling on the solar panel, it is able to harvest, or it is able to convert that light energy into electrical energy. And all of us know that this electrical energy is DC in nature. It's a direct current, and moreover, it is unregulated. Why? Input power that is being impinged on the solar photovoltaic panel is an unregulated. Of course, the solar photovoltaic that also produces unregulated DC power, right? So this unregulated DC power cannot be directly connected with the battery for the battery charging. Of course, this unregulated power has to be regulated with the help of your power electronics converter. We can say a DC to DC converter that convert uncontrolled DC into controllable DC, that the DC power that is being further inverted into an alternating current voltage that will be injected into the utility grid in the form of active and reactive power. Right. And however, as we use energy storage as when the demand exceeds the grid power, then the solar photovoltaic supplies via battery. Right. So it means the energy that stores the battery via battery charger. Of course, this is the bidirectional. Once the battery is fully charged, when the demand is more than the supply, then the battery will further discharge the energy so that it is able to make energy management system. Right, and I told you that solar photovoltaic, the energy conversion is very low, and that energy is being converted from light energy into electrical energy at a very low conversion efficiency, not even 20%, according to second law of thermodynamics. As we use a power electronics converter, they act as maximum power point tracking devices. So with the help of a typical algorithm, with having a number algorithm on maximum power point tracking, and you know the typical characteristics of the solar photovoltaic array as having ideally the solar photovoltaic can produce the power at a maximum voltage in the x-axis and having the maximum current in the y-axis. Of course, the maximum power contained by the solar photovoltaic panel, it is theoretically it is the short circuit current multiplied with the open circuit voltage, and practically the power that is being extracted by the solar PV array is the multiplication of VMPP, that is a maximum voltage and corresponding to maximum current IMPP, right? But however, if you take the ratio between this VMPP multiplied with the IMPP divided by VOC into IUC, that gives the theoretical factor, what is called the fill factor, right? So this is what the area under the curve, that is what is called the fill factor, right? So it means this point, always the solar cells that needs to operate at this point, always we can have a optimal power multiplying VMPP and IMPP, but this point is stochastic, this point is variable one. So according to the given nature of the change in the current or the change in the voltage, this point may shift downwards or upwards. This is what we need power electronics converter to keep or to regulate this point at a particular point so that you are able to extract maximum possible power. This is what a typical IV characteristics of the solar photovoltaic. Right, as I told you that current of the PV increasing while the voltage and the control output current with corresponding voltage output level of the MPV. That is what we use. This method is what is called incremental conductance method, or maybe perturbing the voltage and observing the power. That is what is called a perturb and observe method, right? As we are maximizing the power output so that we can avoid overloading of the solar photovoltaic as well. This point has to be instantaneously controlled. That is what we use power electronics converters, right? And another very important thing, this energy storage is very important in integrating any renewable energy sources with the utility grid. Right. So it makes sense in power flow, which is of course it's bidirectional. Right. As the power is available at the grid is what is called alternating voltage and current. And then the battery is a source of DC power, so we need an inverter. So whatever be the power that is available with the battery, that is being inverted into AC, that is being injected into the utility grid. All right, and whenever the battery needs power to get charged, then the inverter is, of course, it's a bidirectional converter using IGBT at the MOSFET, so that this required DC power is being used to charge the battery as well. So it makes power flow is bidirectional, right? And this is what these converters are basically bidirectional converters and the inverters. It means during AC it means DC to AC conversion. During battery charging means AC to DC conversion seems to be like a rectification. Right. This is what even you can look at the research and development in this particular area. Still, again, how would you design the inverter? right? What would be the configuration of the inverter? Either it may be a 2-level or the 3-level or the multi-levels, or what could be the nature of the inverter? Either it may be a voltage source inverter, or maybe a current source inverter, or maybe a matrix converter, or maybe a Z source inverter, or maybe a cyclo inverter, right? Or maybe, and further, you may have a DC to AC. Maybe you can have either without any kind of isolation. Either it may be a non-isolated or maybe an isolated. Either it may be a full bridge or maybe a half bridge. We have a number of configuration in designing this AC to DC or DC to AC inverters. Of course, you can explore more on this particular topology, right? And another thing, if you see the different types of batteries are used in today's power system, of course, there are 6 types of batteries that are very popular for high power as well as low power application: lead acid battery, nickel cadmium, and the nickel iron, and the nickel NiMH, that is the nickel metal hydride, and lithium ion based or nano titranate. Right. See the cell voltage of each battery is about hardly 2.0 or 2.2 volt, but still the lithium ion based batteries produce the voltage about 3.6 volt. Right. And see the power density as well as the efficiency. And the lithium ion based is having a good energy density is about 160 kilowatt hour by kg. And of course, the efficiency is about 99%. Lithium ion based batteries are quite popular for renewable energy applications. Right. And also we have a lithium cobalt oxide. That battery still it provides a very high energy density. Lithium iron phosphate, and it's quite better for the safer operation as well, because there would be a kind of explode while the batteries are fully charged or maybe overcharged. That may cause the problem. And moreover, and regarding this battery technology for renewable energy integration as well as for IoT enabled smart grid environment, but still the choosing an optimal size of the energy storage is a very still challenging task. So optimal design of energy storage is a challenging task, and optimal location of energy storage in the microgrid environment is a still challenging task. And apart from that, the challenge what we face is in modern power system, how would you recycle the batteries? You know, it is a very challenging task. Recycling the battery, the hardly the lifetime of the battery or value, the lifespan of the battery is about hardly 48 to 60 months, right? So it means hardly 4 years to 5 years only. So after that, how would you recycle the battery? And the materials, it's a challenging task. Another very important thing is today, that is what now the problem associated with the electric EV technology with the battery energy storage. Still, it's a challenging task for recycling. Same thing, even the solar cell as well. So, the lifetime of the solar cell or the solar array or solar panel may be about 20 to 30 years. After that, how could you recycle the solar cell? It is or material. Still, it is a very challenging task, right? And you go to choose according to the nature of application, either maybe grid connected or maybe EV applications. And another very important thing for a very high energy storage application in the order of megawatts level is a hydrogen energy storage device. That is called hydrogen as a fuel. Of course, we use the electrolyzer as we make. This is what the hydrogen storage tank, and we store hydrogen. So it means once the water is being given to the electrolyzer, and alternative energy stores as whatever the nature is available, as we are able to extract oxygen as well as we are able to separate hydrogen. So this hydrogen is used to be stored in the tank, so that this may be a fuel for the fuel cell. So fuel cell, as you are providing hydrogen as a fuel along with the oxygen or the air, so that there will be a chemical reaction. It is able to generate the DC power, still water or the steam as a further waste. So right, this is what the fuel cell. This is one of the emerging technology. One of the beauty of this fuel cell as compared to battery is that the fuel cell is the best candidate for steady state operation of any utility grid. One of the drawback of the fuel cell based power system or renewable energy is that the dynamic response is very poor as compared to batteries. That is what this technology is not so popular for EV applications, because EV application, the energy storage device should have a good energy density in addition to excellent transient response, because whenever there would be a sudden transition in speed or sudden change in load, still the energy storage must cope up with such abrupt change in the voltage and current, but fuel cell can't. That is what, but still it's quite popular for the storing the energy in the form of hydrogen, right? And this hydrogen energy storage, as of course, it's generating a DC power by reacting to the H and O2, and water, the steam are released as a waste, and still the conversion efficiency is very low. It's about less than 30%. Still we need a converter or the power electronics converter to extract maximum possible power. But however, as we use the hydrogen as a fuel, that has to be stored and transported via gas side, still the capital investment is quite higher in the hydrogen energy storage devices. But see, the electrolyzer best efficiency is about less than 85%, but the fuel cell efficiency is about 33%. But commercially, the efficiency would be less than 30%. Right. At best, use such MPPT tracker, you are able to achieve up to about 45 to 50% of energy efficiency. Overall, as I told you, hydrogen energy storage about 30% efficiency, even much lesser than battery energy storage. This is not so popular for kind of any critical loads or maybe for a renewable energy storage. But still, this is one of the alternate for EV applications. Right, the energy density is quite higher than the battery, and higher energy density than the batteries. This is what you are able to store the energy in the form of hydrogen with a very high level. Right. Other energy storage devices for EV as well as for inverter DC link voltage called ultra capacitors. They call it, sometimes we may call it a super capacitors. So still the voltage level of the super capacitor of the each envelope is about 2.7 to 16 volt. You see the beauty of the ultra super capacitor, the response is very faster than the batteries. This is what these ultra capacitor, super capacitors are very popular for the inverter operation, especially for designing a DC link capacitors. We use such capacitors when the demand is very high. Then the inverter output rating, then it is more than the demand, and of course sometimes the inverter may be over. What is called the overloaded. Right. For such application, to supply the power, at instantaneously, sometimes the DC link capacitor may be a super or ultra capacitor, and so that it makes sense in improving the dynamic response when there would be a sudden change in load or whenever there would be an abrupt change in current as well. Right. But still, the energy density is quite low and high price. But however, it is acting as an assistive energy storage devices with the batteries. Of course, it improves the dynamic response of battery energy storage devices as well. Sometimes you may go for hybrid energy storage devices, like you can use the battery along with the ultra capacitor. So by incorporating this ultra capacitor, it largely improves the dynamic response of the entire hybrid energy systems. Right. Other energy storage like a superconducting magnetic, this is quite very popular for supplying power in terms of megawatts level for a short duration. This is one of the technology for supplying for improving the reliability or to restore the energy when the grid abnormal condition like grid fault conditions. So as we use superconducting magnetic energy storage system, we use the superconductors. Of course, here the energy is being stored as a DC current at a zero temperature. The zero resistance. So that is what, but a very high temperature, but the resistance would be zero. So of course, the energy stored in the superconducting coil, that coil offers a zero resistance. So very high inductance, it is a very high inductance is important in storing the energy, but however, it should have extremely very low value to offer zero resistance at the room temperature. Right. So current freewheeling in the coil so that it stores the energy in the form of LA square, in the form of electromagnetic field. But still, it's not much mature technology for energy storage, still having the problem of designing such energy storage for very high power application, and the capital investment is quite concerned in renewable energy integrations. Right. And further, as I told you, it's a very high cost for cold support for the coil. Right. Now, in addition to that, sometimes we may use for renewable energy storage with the electromechanical system as well, like the wind energy conversion system or micro hydro. Right. As here, we use the power electronics converter as a variable frequency to constant frequency converters, because as an this is a typical wind turbine system. And that produces a mechanical power, converting the kinetic energy of the wind into the mechanical power. That mechanical power that drives your generator so that the generator is able to produce electricity. Right. But initially, the turbine may not run as the wind velocity is not much high. That time, this machine can act as a motor. This is what is called a double-field induction generator, or we call it as the slip ring induction generator or induction machine. Right. So during subsynchronous, it acts as an induction motor. During supersynchronous, when the motor is allowed to rotate at above synchronous speed, then the machine is set to be a generator. It is able to generate electricity that energy is being returned to the supply. right? But still, the controlling is possible to control the stator voltage and frequency with the help of AC to AC converter on the rotor side. This is called as double field induction generator, because the energy can be extracted both from stator as well as rotor. This is the one of the machine it able to produce the power more than its rated. Why? Here you're producing the power, what is available in the air gap power. Further, you are producing the power, it is S time. This means you are recovering the energy that is being dissipated in the form of heat in terms of copper loss. This is what is the rotor copper loss being recovered in addition to the air gap power available in the stator, right? And however, making the constant frequency output, because the grid needs the constant frequency AC supply and sometimes the constant frequency AC voltage as well. And sometimes instead of having a single converter, we may have AC to DC and DC to AC converters. We may use with the DC link capacitor, that is called active front-end converters, that can be incorporated between the rotor and the supply. Sometimes we may use the matrix converter having an 80 switches in the array of matrix, so that it could be able to make conversion of AC into AC as well. That is why typically a cycloconverter, but still cycloconverter it is usually made up of a thyristor still problem associated with the response as well as and they always operated the under frequency of less than 50 hertz. This is what mostly the bidirectional or DC to DC, DC to AC converters are very popular for renewable energy application, especially for wind energy conversion system uses double field induction generator, right? And here the squirrel cage induction generator is even still popular for a very fixed frequency application, having the turbine. It is allowed to rotate at a constant speed. As when the turbine is allowed to rotate at a constant speed, but still the speed is above the speed of revolving magnetic field or the speed of rotating magnetic field or the speed of synchronous speed, you are able to harvest, you are able to generate electricity by operating this machine as an induction generator. Then that variable voltage and variable frequency generated by this induction generator, that is being given to AC to DC converter and DC to AC inverter via DC link. So you are able to get a controllable AC power that is being injected into the utility grid, right? So this topology is what is called an active front-end converter, right? But however, both converter uses IGBT or MOSFET for making bidirectional powerful, right? Another renewable energy integration, as we use a synchronous generator. And this is one of the very popular method for very high power electricity generation in terms of megawatts level. The synchronous generator is very popular, especially permanent magnet synchronous generator. Even a single generator can able to generate the power up to 20 megawatts. You know, because as the generator uses the rotor, it uses the permanent magnet. It has a very high energy density. And this is one of the prime candidate for the wind power, the tidal as well as hydropower, right? And we uses that as still here the machine is allowed to run at a constant speed, at the synchronous speed. It is able to produce the constant frequency. That frequency is being injected into the AC supply. So it means it has an auto synchronization that the machine is allowed to rotate at a constant speed. It produces the power at a constant frequency. This frequency is well synchronized with the AC frequency. Right, this is what a synchronous generator, either it may be a permanent magnet or maybe switched reluctance generator, as we use it with the DC to DC and AC to DC and the DC to AC inverter as well, right? And now, of course, we understood that these renewable energy and energy storages are very vital in modern power system in association with IoT. And now you understand that a modern power system, how it would be. So how it makes sense in automated power system, that here you can understand that the wind power, having solar photovoltaic, the bio power generation, and further from the bio power, and we extract hydrogen that is being used as a fuel for fuel cell, and these all renewable energy sources generate a DC supply with a common DC bus, right? Further, for that the DC power is being used for rail transportation or maybe electrical vehicle with the EV charging, or maybe for building power distribution, or maybe street and traffic light, or again we use in hydrogen energy storage, right? So now, according to the demand, further see from the building power distribution in the smart home environment, we have LED lighting, motor drives and computers and audiovisual entertainment. And here we use the motor drive for elevator, escalator, and air conditioner. And further, we have a waste food as well. That may be input fuel to the biopower generation. So it makes sense in that we harvest energy with the help of with the help of these all renewable energy sources, and we are able to generate a DC electrical power. And this bus voltage has to be maintained constant, so to meet the entire power of the load, so we use energy storage devices. This is what the renewable energy network, right? Maybe and this is what and we could emulate this the typical modern power system, how this has a different types of load. In overall, you understand that here we have two common DC buses. Here is a DC bus, and again you have a DC bus, and the nature of the loads are all DC. Of course, the feature grid would be a DC grid. Feature grid would be a DC. You can instantaneously control the voltage and current. It doesn't need any support of reactive power. It doesn't need any support of power factor improvement. It doesn't need any support for frequency control. Now, the feature power system would be a DC grid. Making control parameter is a simple DC supply, current and voltage. The control is very straightforward, and still it makes sense in overall improvement in the grid network, and also control and easier control of DC voltage and DC current. Right. So in overall, and coming to this, the summary about this post 1 hour information on the IoT for electrical power and energy system, the important role of IoT in transforming electrical power and energy systems was presented here. Of course, the digitizing the electrical power ecosystem using IoT, it helps to better account for the distributed energy resources integration. Of course, it reduces the energy shortage, and there would be a large leveraging the generate saving, and it improve the efficiency and reliability and resiliency and the security as well. Right. In addition to that, this Internet of Things for EPES has a significant impact on the economy and the society and the environment, and in terms of increased value of electrical power and energy systems, reduced CO2 emissions and life cycle convenience and public safety, energy conservation and expense reduction, and etc. And addition to that, this IoT can help reduce the power losses and the data theft during transmission and distribution by adjusting this all electrical parameters in terms of voltage, current, power, and the phase in real time by tracking the source of theft respectively. So in addition to that, as making your systems, the power system is a modern power system or the intelligent power network. And of course, it makes sense in incorporating renewable energy sources along with the energy storage. So now your overall power system is going to be a decentralized power system, and it has an intelligence in automatic adjustment of the all electrical line parameters in terms of line current, voltage, frequency, active, reactive power, power factor, and all. And it also detect the fault very accurately. It is able to diagnose the fault in the utility grid as it is a self-healing operation as well. So in overall, the feature power system would be the smart power system, thanks to Internet of Things and thanks to wireless technology, because as we use a very precise sensor in detecting the entire system parameters, making system is more affordable. And also the next generation power system would be incorporated more with the energy storage devices like ultra capacitor, super capacitor, battery energy storage devices, and also superconducting magnetic energy storage as well. Right, and also the feature power system is called as the intelligent network or the smart grid network, everything, because of incorporating power electronics. So you can't imagine a modern power system, or you can't imagine a today's power system without power electronics. So power electronics, it became a part of the power system that become a modern power system. Because with the help of power electronics control, you are able to control entire electrical parameters with the help of simple solid state electronic devices. It makes sense in the entire automated power system. Right, it makes sense in energy efficiency. It makes sense in energy saving opportunities. So entire system is going to be completely integrated in terms of renewable energy, solar photovoltaic, wind energy, hybrid energy, and the DC bus with the DC grid, or maybe a nano grid, or maybe in the microgrid in terms of scalability, and again in the control aspect with power electronics converters with a different topology. Right. In addition to that, of course, as the future transportation would be electric vehicle, that is EV transportation, and again and designing or manufacturing such electrical machines for EV applications. Again, it is a crucial task. And again, and it also poses the difficulty in the grid infrastructure as well as grid stability as well, because as the charging mechanism is again stochastic in nature, so of course it degrades the stability of the utility grid. So in the future power system, how would you enhance the stability of the utility grid when the electrical vehicles are charged, when the EV charging stations are well established? It is a challenging task. How would you cope up with such stochastic nature of the charging mechanism with the utility grid? Of course, we have to more focus on the grid stability as well. So IoT can make, IoT can able to make the system is very comfortable, but it cannot support for improving the stability of the grid. This is what another difficulty is going to be encountered by a modern power system. It means when EV vehicles are being charged via charging station, how would you make or how would you enhance the stability of the utility grid? Still, it is a challenging task. Okay, so with this, and these are all the key references in setting the slides, as with the help of different types of IEEE transaction and IEEE journals, I would make a kind of the detailed description on IoT based electric power and energy systems. And thank you very much for your kind attention. If you have any doubt, please let me know. Yes, please.
Sir, am I audible, sir?
Yes, please.
Yes, sir. So thank you so much, sir.
Yes, you are not audible.
It was a very good, clear lecture. Sir, seriously.
Shankaran sir, your voice is breaking.
Because we don't know that IoT. Am I audible?
Yes, yeah, you are audible. Yeah, you are audible.
Yes, sir. Thank you so much, sir. Actually, it's a very clear-cut explanation, sir. We even don't know that power system is having these much kind of advantages with an integration with Internet of Things and all its facilities, sir. Thank you so much for a clear inside view on IoT on this power systems.
Yeah, thank you very much.
Thank you, sir. Ma'am, is there any question and answer session from the participant sides, ma'am?
Yes,
Good evening.
participants wish to ask any questions, you may interact with the resource person. Sir?
Good evening, Chetty Babu sir.
Yes, it is a good evening, madam.
Very good and enthusiastic presentation. A very crystal clear explanation about the presentation.
Yeah, thank you, madam.
So IoT at small scale, like smart home applications and even in industrial applications, IoT in small healthcare applications and all, we are able to imagine. And
Okay.
we have explained about the future grid is going to be a DC grid. So this IoT applications is very easily feasible there.
Yes.
But is there any hope, or is anywhere in any part of the power system prevailing? This IoT is implemented in our country, sir?
Yes, madam. Yeah. Madam, IoT, for a smart city project, a number of IoT based smart grid as well as smart cities have been implemented. The very first smart city is Bhubaneswar, and even Pondicherry, they could make a kind of smart city. So they made it a kind of smart grid infrastructure with the smart metering concept, making well automated the smart home. So they made it. But still, modernizing the entire city in India, still it is a challenging task, right? Yeah.
Yes.
Yeah. But for countries, almost all Western countries, they made a smart grid enabled infrastructure, and having this IoT, they could be able to make a automated power system for regulating all the parameters and monitoring all the grid parameters. They made the technology was well established in the Western countries, but still maybe a couple of decades it took to make complete automated power system in India.
Okay, they have implemented with the AC grid, isn't it, sir?
Yeah, AC grid, they made it better. Yeah, but still, again, as I told you, that having number of difficulties with the AC grid, because AC grid is well established across the India and having 5 regional grids, but still problem associated with the grid stability, because all of us know that our Indian grid is very weak grid, having very low short circuit ratio, and there would be an abrupt change in the grid parameters. It poses the grid instability. And again, the supporting the reactive power for the transmission as well as for improving the power quality still is a challenge with the existing grid. But once we make the grid is a DC grid, having, because most of the loads available at our home is all a DC load. Naturally, we have all renewable energy sources of solar, photovoltaic, and the battery, or even source. It is quite easy to cut through the DC parameters than the AC parameters.
Yes, sir. Yes, sir. Thank you. Thank you, Siti Babu, sir.
Thank you very much. Of course, tomorrow I have another very important session. So as that I am going to deliver a talk on grid code requirements for integrating solar photovoltaic with the utility grid. Still, it is a very challenging task. It's a very informative discussion I will make tomorrow in my next session. Grid code requirements for solar photovoltaic power system. Right, that also it makes sense in improve understanding the stability of the grid and what are all the important requirements to be meant by the renewable energy manufacturer according to the power system operator. That I will discuss tomorrow. Yeah, thank you very much.
Okay, sir. Thank you.
Yeah.
Thank you, sir. Thank you for your valuable presentation. And really, the session is so interactive and useful for all the participants, I think so. As sir correctly said, the session will not over today. It will continue tomorrow also. Thank you, sir. We are all waiting for your tomorrow's lecture also, sir. Thank you, sir. Thank you so much, sir.